Explain like I'm 5. Why do planets orbit at the same level as each other? By that, I mean, why do planets always orbit horizontally around the sun? Why not vertically? Space is a 3D space. I'd course. So why would the planets not end up going up as well as sideways? Edit. Space science is a lot more complicated than I thought. And I am here for this rabbit hole. Tie everyone for your answers so far. Imagine you and 9 friends going down a wide waterslide. At the beginning you are bumping into each other a lot. But as time goes on, you find yourselves going more or less parallel and collisions are more rare. By colliding you have evened out your sliding direction. Most big stuff in our solar system orbit in planes in the same directions because the average motion of all the things colliding around that gravitational center was going that direction to begin with. There is only one equilibrium but many ways to be uneven. The planets come from the same stuff. Before there were planets there was a big spinning soup of stuff around the young sun. All the stuff that would later become the planets was in this big, very fast spinning soup disk. Because we were all spinning in the same soup, it all flattened on the same plane. Then gravity made stuff congeal into planets. Because they all coalesced over time out of the same spinning disk of matter. It mostly collapsed to the middle and formed the sun. But clumps out in the disk collapsed into the planets. But it's all the same disk of matter still spinning. They don't. It seems like it, but their orbital inclination can be way different. See Kerbal Space Program for a good example of how this works in a relatively simple format. No answer for you. But I think what you're looking for is planar movement. Or why the planets orbit roughly on the same plane in 3D space. Not horizontally. Essentially, after the sun formed there was a 3D cloud of dust around it. Over time as this dust collided it flattened out into the protoplanetary disk. This was a flat plane that sat at the same inclination the planets now sit at. The reason the planets all orbit in more or less the same plane is because the materials they formed from were orbiting in that plane from the disk. Also, angular momentum is very powerful and it requires a lot of energy to change orbital inclination. All the planets formed from the same spinning, collapsing cloud of gas that the sun formed from. So the starting conditions made it such that every body that formed from that cloud has the same rotation and orbital plane. The only reason anything is different is the 5 billion years of gravitational interactions and collisions that have happened since. It minimizes the kinetic gravitational energy of the system for a given angular momentum. Angular momentum and energy are both conserved. But energy can be and usually will be, if possible, transformed into heat. Further adding to Op's question, how self-correcting is the orbital plane? During the early stages of the solar system, some major collisions occurred such as Earth and Theia. The extreme axial tilt of Venus may have been caused by a massive impact. Perhaps many of the early protoplanets that suffered these impacts are no longer part of the solar system today. But how much deviation to orbital plane would these events generate, and how did the present solar system restore its plane? Others have answered the question. So I just wanted to point out that the word planet comes from the word plane because all the planets orbit on the same plane roughly. Angular momentum. The masses retain their angular momentum around the center of mass of the solar system even as they coalesce into planets. A planetoid that doesn't spin in roughly the same plane as the rest of the system is a sign of a captured rogue. It could also have had its spin axis upset by some catastrophic event, but that requires enormous energy. If you imagine a whole bunch of objects suddenly appearing and spinning around a center in all different types of orbits, what will happen is that they will interact with each other. The interactions will have one of three outcomes. Either an object will gain energy, go to a bigger orbit with the result that it escapes the system, or lose energy, go into a smaller orbit with the result that it eventually falls into the center sun, or if they are big enough they may combine gas giants. What will remain is only the objects that are far enough apart to not interfere with each other. The sun is really heavy, and the planets aren't very heavy. So the planets orbit the sun. But now those planets are in an orbital plane around the sun. And the planets have mass too. So they attract other stuff. That new stuff joins the orbital path of the first stuff, and starts pulling new stuff of its own. That causes an orbital plane to form around the star. Mass always attracts mass. But the attracted mass then does stuff too. Is this why the Earth's and Moon's craters are so old and no new craters are being formed? Are formed very, very rarely? Were the craters a result of the early chaos and as things to collide with? The solar system was formed from a big cloud of spinning gas. The spin and pull from the center, what became the sun, caused it to flatten over time into pretty much a disk of gas and dust. When this condensed into the various planets, they carried on spinning the same way they already were. Conservation of momentum, meaning they all orbited in the same plane. Not sure this is explained like I'm 5, but it is better than others at least. Orbits of planets and other masses attract each other. Even when they weren't on the same plane long ago, they are slowly being attracted into having same inclination. This effect is gravitational. So the bigger and closer the planets, the more the orbits look alike. If you spin a disk or a plate on a table, will wobble around a lot before it settles. A similar thing happens with all the stuff that eventually forms a big disk of matter around a large gravity point like a star. And then planets form from that already orbiting matter. First, imagine the planets not lined up. Now, as they spin, imagine the gravity of both planets pulling on each other while they orbit. Whenever they draw close in their orbit, they pull up or down towards each other, slightly changing each other's orbital skew. If they ever overshoot, then they'd just pull up and down the other way instead. Eventually everything sorts itself out, one around one axis, around the average of how everything was spinning to begin with. Imagine holding a string with each hand with something tied to the end of them. Then spin around. The two objects will settle in the same plane. Think of it like sand in a bottle. If you keep shaking it, they will settle to a uniform flat surface on the open side. Our current hypothesis is similar. The particles that formed the planets hit each other, similar to shaking, and settle to a flat surface on both sides as both sides are open. Also, there is no such thing as vertical. The mechanism makes sure that it is flattened, but the final angle of the plane is random. Our solar system is at a 60° angle to our galactic plane. Accretion disks forms along one plane, so as the planets formed from the space material left over from the formation of the Sun. They all formed roughly along the same plane as the accretion disk. Accretion disk is a stage before planet formation. Think of it like starting with a ball of pizza dough. The pizza maker spins it and it flings out flat. With planet formation it's not too dissimilar. Except you have multiple factors beyond centripetal force, angular momenta, gravity, particle charge. There are things that do not follow this orbital plane but are on highly irregular orbits and/or are beyond Neptune, the Oort cloud. Sun is moving around the galaxy. Our planets are dragged along the same axis that the Sun is moving. That's why no planet rotates the Sun in a perpendicular plane. Does this apply to the universe in general? I've always wondered, since we can detect planets by seeing their stars dim when a planet crosses its path, how many more planets are there out there where they don't orbit in the same plane as our solar system?